हेलो एवरीवन। तो आज का अपना टॉपिक है प्रोजेक्टाइल मोशन। प्रोजेक्टाइल मोशन and in this lecture we will see what is the projectile motion and the application of the projectile motion. Then what is the projectile motion? The projectile motion is under motion under the constant acceleration. Motion under constant acceleration due to gravity. Due to gravity is parabolic. Is known as projectile motion. We can write short form PM, not the Prime Minister. This is the projectile motion. Okay, but the first thing we can do that under the constant acceleration due to gravity, there are two type motion, one dimensional and two dimensional. We will see how the one dimensional motion come and how the 2D dimensional two dimensional motion come. The projectile motion is two dimensional motion. Okay, so we will talk about constant acceleration due to gravity, and we know that gravity is varying when we change the height of the object. So we will talk about this is the our earth. So we will talk about the small heights from the surface of the earth, because at small heights the gravity is constant. Like this is the surface of the earth we will show here, and we will talk about this type of motion. We will not talk about the types this type of motions, like aeroplane going from here to here. Assume this is the country India and this is the New York. So we will not talk about this type of motion because here the distance is very large from the surface of earth. So here is the gravity, and there is gravity G and there is gravity G dash. So gravity at these point are changing, but at small heights from surface of earth gravity is constant, is G is equal to 9.8 meter per second square. So we will talk about only small heights. Now let's talk about 1D motion, how the 1D motion is come. First let's assume this is the ground, and when a object is at rest and it will fall in a straight line due to gravity G. Its initial velocity is 0 because it is at rest, and this will be free fall, and we will assume here air resistance is 0. And second, when we give the some velocity to a object v, u, and this will be also a straight line motion, and so this is also a 1D motion. And if we throw a object in vertically upward, then this is also a 1D motion. It will goes up to some height. It will go some height because the gravity is downward and velocity is upward. So first velocity decrease and then it will come in rest at some height h, and then it will again accelerate in direction of gravity, and this will be also a 1D motion. Okay, but for this is the 1D, there are three cases, and for 2D there is a surface of the earth and we can see ground, and if we projected a particle at any angle theta from horizontal axis, we can say that this is the x axis and this is the y axis. This is the y axis. If we project a particle or body or any object at any angle theta, then due to gravity is downward. Due to gravity, the motion will be parabolic motion, and this motion is known as projectile motion. Okay, and here theta cannot be 0. Theta will be 0, then it will be 1D motion, and theta cannot be 180 and also 90 because we also study the 90-degree case from the horizontal. So this is the projectile motion. This is the angle theta from the horizontal, and this is the velocity u, initial velocity of the object, which is projectile. The object is known as the projectile, so is called the projectile motion because the gunfire and also the some weapons when fired, so then the bullet is known as projectile. So this motion is also called the projectile motion, and its initial velocity is u, and this is the y direction, y axis, and this is the x axis. Then when we resolve the velocity u in x direction and y direction, then there will be two component of the velocity. First is ux is equal to u cos theta and uy is u sin theta. And we know that the gravity is in the y direction downward, or we can say the negative y direction, and in x axis there is no acceleration, only acceleration in y direction is minus g because the gravity is downward. This is the positive direction of y and this is the negative direction of y, so ay is equal to minus g. So throughout the motion the component of the velocity in horizontal direction is ux. It will be constant throughout the motion because the in x direction there is no acceleration, so this will be constant throughout the motion. And uy, first the uy is u sin theta. First this component will be decreased, and at maximum height the uy will be 0, and after its increase, so uy is changing throughout the motion, and this point is known as the projectile point of the projectile, or we can say the point of the projection. And the angle is the point angle of projection, and this point is where the particle hits the ground is known as the, we can say, the collision point and the hit point. And there is some application of this projectile motion. First is time of flight. What is the time of flight? This is the point O, this is the point A, and this is the point B. When the particle goes through this path OAB, then the time taken by describing this path by the particle is known as the time of flight. And we can say that for what time particle fly in air, and for path OAB, in what time the particle describing the path OAB is known as the time of flight. And we know that at the maximum height the y component of the velocity, or we can say vertical component of the velocity, should be 0 because the particle at maximum height and the particle will not go above this point. So at this point the velocity in vertical direction is 0. So here we know that acceleration is constant, so we can use equations of motions like v is equal to u plus at, v square is equal to u square plus 2as, and s is equal to ut plus half 8t square. So we know that at maximum height vertical component of velocity 0. So here we can use second equation. Here v square is equal to u square plus 2as, and v square, this is the vy square, uy square minus 2g, because minus due to the acceleration in negative y direction, and s will be the, we can say, the displacement in y direction. So this will be the h maximum, and v square is equal to 0 at this point. So uy square is equal to 2gh maximum, and h maximum is equal to u square. What is the u square? U square was u sin theta, and u square sin square theta upon 2g. So this is the maximum height of the particle, and this was the maximum height of the particle. And when particle reach O to point B, then this distance, or we can say O to B, is the distance in the x-axis, or this is also the displacement in x-axis or horizontal direction. So this is known as horizontal range, or generally we can say range R. And at this point in y direction, displacement in 0, and also at this point in y direction, displacement is 0. So we can use this equation. We will put Sy is equal to 0, because in y direction, in vertical direction, displacement is 0. And we also put the all things, and we can get the horizontal range, the particle, and here is the one thing that we also calculate time of flight. Okay, what will be the time of flight? We said the y direction, in x direction, in y displacement 0. Okay, so at b point in y displacement in 0, so we can put here Sy is equal to uyt plus half 8t square. Then Sy is equal to 0, and u sine theta into t minus half g t square. So here we can take common the t, and one value is t is equal to 0, and other value is t will be 2u sine theta upon g. So this is the time when the particle is point O, and this is the time when the particle at B. So this is the time of flight of the particle when the particle come to point O, to point B, to point A, to point B. So this is the time of flight. In this time the particle complete the motion, and this is represented also capital T, 2u sine theta upon g. This is the time of flight. And this is the point O, this is the point B, and this is the range. So V is equal to U plus 80, and in y direction the velocity is not changing, so we can say that U is equal to R upon T, and R is the Ux into T, and we can also use the S is equal to S x Ux T plus half Ax T squared. Ax in x direction is 0, so this will be 0. So we will get x is equal to ux into t, and this is the horizontal range. Ux is the u cos theta, and T is the time of flight. This is the 2u sine theta upon g, and this will be, you know that 2 sine theta cos theta is equal to cos 2 theta, so u square sine 2 theta upon g, and this is the horizontal range of the particle. So time of flight is the 2u sine theta upon g, and horizontal range is the u square sine square theta upon g to g, and horizontal range, sorry, maximum height h maximum is the u square sine square theta, sorry, this is the u square sine 2 theta upon g, and maximum height is the u square sine square theta upon 2g. So this is for the this projectile motion. Here the point of the projection and the point of the collision, it lies at the same level, but projectile motion also the type when we project a particle or object from height h from the ground. We can say we can project a particle from a tower or a building. We can project this type velocity in this direction. We can project at this angle. This is the in vertical, then it will be this, and we can this type. So in this type of projectile motion, we cannot use these formulas. These formulas will be used only when the projection, point of projection and the point of collision are lies at same plane, same horizontal plane, same horizontal line. Not will be plane, same horizontal line we can say. So in this case we will use, and in this case we can use like this type. If projectile motion this, then for here to here we can use these formulas, but for not complete projectile we cannot use this formula directly. And projectile motion are also this type. If we, this is the inclined plane, and we projected a particle from this point, then it is also a projectile motion. And if we projectile a particle from the upward downward direction from the inclined plane, and this is the upward direction from the horizontal plane at inclined. So these are also the projectile motion. So for today this is enough. I hope you will understand. If there is any problem you can comment, and we can discuss. So thank you, and subscribe this channel for more videos. Thank you so much.